use Lewis symbols to show the transfer of electrons between the following atoms to form cations and anions. Let's take a look. We're getting ionic bonds. Potassium and sulfur. Now potassium is in group 1, it has 1 valence electron, and sulfur is in group 16, it has 6 valence electrons. Sulfur actually, from 6, in order to complete an octet, it would need 2 electrons. On the other hand, I hope you can see that potassium is capable of giving only 1. So is this a good match? If not, who says there is only 1 potassium atom? Take 2 atoms. Oh yeah. So what shall we have? Just imagine it like this. And just for the sake of convenience, let me say color the potassium electrons as black. Now electrons, please remember, have no color as such. I'm just doing this for the sake of your convenience. So sulfur has 6 electrons of its own, yes, and it is going to borrow 2 electrons from potassium. Not borrow, rather complete transfer. So you get sulfide ion. Wow. And you have 2 potassium atoms. You get 2 times potassium atoms. That's it. That's it. Simple, very simple. What about calcium and oxygen? Calcium has 2 valence electrons. Yes. And oxygen has 6. So if calcium loses electrons, yes, it has 2 valence electrons, it will throw away both. So it has +2 charge. What about oxygen? As oxygen gains 2 electrons, it would become -2 like this. The black electrons are the ones which have been acquired from calcium. This is how cations and anions are formed, and this is how an ionic bond is established between calcium and oxygen. What about aluminium and nitrogen? Aluminium has 3 valence electrons, and nitrogen, the stupid one, has, why you call it stupid? I just don't like nitrogen much. 1, 2, 3, 4, 5. I have nothing against it, no racism for nitrogen, but still, just a personal choice. Like you like red color, something like that. Now, aluminium will lose all the 3 ions. And please remember, losing 1 electron is easier than losing both 2. And losing 2 is easier than losing all 3, which is, much more painful because you're losing 3 electrons. But nonetheless, aluminium manages the sacrifice. And nitrogen, 1, 2, 3, 4, 5. And then you get 6, 7, 8. Nitride ion. This is how you get the ionic bond for aluminium nitride.